All right, let's look at how to calculate the relative atomic mass of isotopes. In the previous video, I explained what isotopes are, but just to go over it again briefly. Elements are made of atoms that have the same number of protons, right? So the number of protons determines the element. So if an element has 3 protons, if an atom has 3 protons, it would always be lithium. If it has 29 protons, it would always be copper, etc. So the number of protons never changes. But we know that the number of electrons and the number of neutrons can change. So these electrons can lose or gain electrons. So atoms can lose or gain electrons so that they have a full outer shell of electrons. That's ions. We're looking at isotopes today. Isotopes are when atoms lose or isotopes are when atoms have a different number of neutrons. They don't lose or gain neutrons. It's not that process, but it's when atoms have a different number of neutrons. So there can be isotopes of different type of elements. So there's isotopes of copper and carbon, etc. So the atoms can have a different number of neutrons, so the negatively charged stuff, right? Let's take a look at copper as an example. There's 2 types of copper. There's copper 63. We write them like this. There's copper 63 and copper 65. So these isotopes basically means that there's more than one type of copper with different numbers of neutrons. So there's only 2 types of copper, copper 63 and copper 65. Now what this means is that if you pick up a random copper, it can either be copper 63 or copper 65. So copper 63 and copper 65, these are called the isotopes of copper because they have a different number of neutrons, right? Now, what do these numbers mean? So copper 63 and copper 65, like what do these 63 and 65 mean? Well, these tell us the mass. So this number and this number tells us the mass of each copper isotope. Remember, isotopes is when there's more than one type of copper with different numbers of neutrons. So this number tells us the mass of each copper isotope. Now, if you write them as copper 63 and copper 65, it can be a bit confusing, right? So let's draw a bit of an atomic symbol. So this is something that you'll find in the periodic table. And copper is Cu. So the 63 tells us the mass of each copper, right? So remember, the top number, if you didn't watch the previous video explaining atomic symbols, I highly recommend you do so. But the top number tells us the mass number, which is the number of protons plus the number of neutrons added together. And the bottom number, the smaller number, it's better to call them the bigger and smaller numbers because it can be put in different orders. The smaller number tells us the proton number, so the number of protons. And this is called the atomic number. I should have written them the other way around, but atomic number tells us the number of protons, and the mass number tells us the number of protons plus the number of neutrons added together. So remember, the number of protons determines the element, so the number of protons never changes. If you look at the periodic table, copper always has 29 protons. This will never change. It cannot lose or gain protons. But the number of neutrons can change. So copper 63 has a mass number of 63, and copper 65 has a mass number of 65. That's what it means. So if you want to calculate the number of neutrons, you would do 63 minus 29, because this is the protons, right? So if you minus 29, you'll get rid of the protons in this equation. So you'd be left with neutrons. So 60 minus 29 and 65 minus 29 would give you the number of neutrons. But we don't need to do that calculation. We just want to calculate the relative atomic mass. You might think the relative atomic mass only refers to neutrons because that's what isotopes are, but relative atomic mass, like this mass number, is just the relative atomic mass. So it's the mass number of any copper that you will find relative to their abundance. So abundance is a concept that can be a bit difficult to understand. So abundance basically means how common something is. So first of all, let me tell you the abundance of copper 63. Copper 63 has an abundance of 69.2%. And copper 65 has an abundance of 30.8%. Now, don't worry, you don't need to memorize this. All this information is provided to you in the exams. So the exams will basically tell you there is copper 63 and copper 65 with abundance of 69.2% and 30.8% respectively. Calculate the relative atomic mass. So it tells you the mass number and the percentages, but it won't draw you these diagrams. So it is useful. I'm just doing this so that you guys can understand. So there's an abundance of 69.2% and 30.8%. What this abundance means is that it basically just means how common something is. So if you were to pick up a random copper atom in the world, so theoretically, if you could pick up a random copper atom in the world, you would have a 69.2% chance of that copper atom being copper 63 and a 30.8% chance of being copper 65. So the chances are like so. It's like probability. So if you picked up 100 copper atoms, 69.2 of them will most likely be copper 63, and 30.8 of them will most likely be 65. At least that is, theoretically, on average. So this is the abundance of each copper atom respectively. Okay, so that's basically what abundance is. If you still don't know what abundance is, let me think of it. Let me give you I can't speak, analogy. So it's like you have two models of cars. Car model P and car model C. There's car model P and car model C. Their car model P, 70% of drivers buy car model P, and 30% drivers buy car model C. That means that there's more car model P cars than car model C cars, right? Because there's 70% of car model P and 30% of car model C, right? So there will be more car model Ps than car model Cs. And let's say the weight of car model P is 100 kilograms, where the weight of car model C is 50 kilograms. The average between the two would be 75, right? But it won't be, because if you picked up a random car model from this company, X company, well, there's a higher chance of it being car model P, which is heavier, right? That's exactly what happens with this copper thing. So copper, 69%. Okay, let's do this first. So the mass number, relative atomic mass, is calculating the average mass number of the copper atoms. So copper 63 has a mass of 63, and 65 has a mass of 65, right? So if you drew a number line, the average between the two would be 64, right? 63, that's how you calculate average. 63 plus 65 divided by 2 would be 64. So the middle would be 64. However, what we didn't account for is the abundance of each copper atom. There is way more copper 63s than copper 65s. 69.2% chance compared to a 30.8% chance, right? There's a much higher chance of it being copper 63. So on the number line, it must be closer to like somewhere around here, right? We're not going to guess our answer for your GCSE exams, are you? So how do you calculate it? Well, just multiply 63 by 0.692. To do this, you need to know how to convert percentages to decimal form. But basically, 69.2% means 69.2. So you could write 69.2 out of 100, or you could get rid of the decimal place, so 692 out of 1,000, right? So if you convert 692 out of 1,000 to decimal form, it's going to be 0.692. 3 decimal places because there's 3 zeros. Same with 30.8. 30.8 is 30.8 out of 100, which is equal to 308 out of 1,000. So it's going to be 0.308 multiplied by the mass, 65. So if you do each of these calculations, 63 times 0.692 on your calculator, you will get an answer of 43.596. That'll be the average mass, 43.596. And if you do 65 times 0.308, you'd get 20.02. All you have to do is you add these two up together, and that gives you a weighted average, the average accounting for each of their abundance of roughly 63.616. Now, oftentimes it'll ask you to give your answer to one decimal place. So you only count for one decimal, and you look at the second one. Well, it's smaller than 5, right? So you round down, giving you an answer of 63.6 AR. AR is basically atomic mass, so it's what we call. It means relative atomic mass. It's like kilograms and grams. 63.6 AR. So that's the average relative atomic mass of a copper atom.